Hello everyone and welcome to the rest of the Pandas exercise. So in the previous video we were looking at just importing the dataset. I spent a little bit of time on that because that can sometimes trip people up, but I suspect we will be able to get through the rest of the exercises in a single video. So let's remind ourselves what we've got here. We have imported Pandas as PD and we have imported our Titanic data frame. I have saved that as a variable and therefore it is not displaying. If I were to just run pd read CSV Titanic dataset, then actually we can see what's in the dataset. However, we want to be able to reuse this, so we assign it to a variable called, in my case, Titanic df, df standing for data frame, that's what one of these is, and I've run that. Now, if we want to get it to show up again, then I am just going to I'm going to do this. I'm just going to type in Titanic df and I'm going to run this and you can see it's shown up. Now you might note that I didn't put print Titanic df, and that is because if I run that we get this rather unfriendly representation of the data frame. It's not as nice and intuitive as what we saw a minute ago. Now that's just a little quirk of the way data frames work within Jupyter notebooks, however you want to pronounce it. So I would recommend just referring to the data frame by the variable name that you have saved it as, rather than wrapping that in a print statement. What we have now been asked to do is create a new data frame that contains only the passenger ID, the name and sex fields from the main data. Now, to do this, I am going to take my Titanic DF and I'm going to use two sets of brackets. This is just a good way of saying I just want columns, please. And I'm going to say that I want the passenger ID, I want the name, and I want the sex. Now, effectively, we have passed in a list of column names that we are interested in. And it's very important to match the capitalization that is used in our data frame. That's why it's quite helpful to have it displayed up here. You can see the ID here has a lowercase for the D in ID. Its name starts with a capital and sex also starts with a capital. If we get this capitalization wrong, we will get an error. But for now, if I just execute this cell, you can see that we now have a new data frame that doesn't have all of the columns we were looking at previously. Just to demonstrate what happens if I get the capitalization wrong on one of these, it will come up saying something along the lines of key error. What this is passenger ID is not an index. That's just saying that basically I've looked at all the columns and I couldn't find one called passenger ID spelled as you have spelled it. So I just know that I need to go back and say passenger ID. And if we actually would get a few of them wrong, let's get passenger ID correct, but name and sex, we will get the wrong capitalization. It will say name and sex both not an index. The other thing to watch out for is that it's very important that you are surrounding each individual column by a set of quotation marks. You're not passing in a list that starts and ends with a single set of quotation marks. That's just passing in a string saying please search for a column called passenger ID name sex, which isn't going to work. See, it will just say none of that in the columns. So actually what we need to do is, again, we need to make sure that each one of these is individually surrounded by a column, because effectively we are just passing in a list of 3 column names. So what do we want to call this now? Let me just check what we want to call this particular data frame, and let's just call it something like Titanic DF, so we can call it anything we want really. But the other thing we've been asked to do is print out the first 10 entries of this new data frame. So I'm going to type in Titanic DF name sex, and I'm going to use the head function. Now head, as you can see from the autocomplete that's popped up here, it will return the first n rows. Returns the first n rows for the object based on position. No, don't need to worry about that too much. What we do need to worry about is that the default number of rows is 5. So if we call this without saying how many rows we're interested in, we will just get the first 5 rows. We've been asked for the first 10, so I'm just going to put 10 inside there, and that should now give us the first 10. So you can see actually our index here, the first column is 0 through till 9, and the passenger ID is 1 through to 10. Now, one important thing I've just realised I didn't do, we've been asked to set the column passenger ID to be the index for the data frame. Now, what I didn't do here was basically go index equals passenger ID. So if I run this now, that's not going to work. Why isn't that going to work? Because the argument is index column. I need to tell it that the index column is passenger ID, and you can see now that when this displays, passenger ID looks a little bit different. It's sort of down a row from everything, and we actually then see survived, P-class, and passenger ID. Now, actually, this is going to change this one as well, because if I try running passenger ID at this point, then what we're going to see is that the passenger ID is not in the index. Now, why does that matter? Well, it's because effectively passenger ID is no longer a column. These are our columns. Passenger ID is an index column. That's a special kind of column instead. Now, if I were to get rid of this and just put name and sex, what you will see is that passenger ID comes through anyway. Now, the reason for this is when we do this subsetting by column, when we say I just want a couple of columns, the index will come through regardless. So we only need to tell it about any of the columns over here. We do not need to tell it that we want to pull through the passenger ID that is our index column, because we've imported it now and set it as our index column. That will just happen automatically. Now, next thing we are going to do is we are going to create some data frames that actually contain all the information from the original data, but only for first class, second class, and third class passengers. So let's go back to our original data frame, which is now called Titanic DF. Let's just remind ourselves what that looks like again. So passenger ID survived P class. So I want to only return stuff for first, second, or third class, but I want each of those to be a new data frame in its own right. So let's call it first class data. And what I'm going to do is I'm going to do Titanic data frame dot loc. I'm then going to say I want everything from the Titanic data frame where the column P class is equal to 1. And now if I were to run this, then what you'll see is that we only have, it looks like we've only got the rows, sorry, where P class is equal to 1. Now, let's just have a quick look at what this little bit by itself is doing. I'm going to get rid of all that a second and just say what happens if I run Titanic data frame P class is equal to 1. And remember, it's equals here because equals just means a sign. That would mean I'd make everything in that column equal to 1. It wouldn't exactly work like that, but that's effectively what it's saying. I think we'd get an error if we tried to do that. But this is saying, please check whether this value is equal to 1. So what you can see is we get false, true, so on and so forth, all the way through our different passenger IDs. So when we then run this line, it is going, please look at every row in Titanic data frame, and if you get a true here, keep it in. That's all this is doing. I find this a little bit hard, or I remember when I first started out, I found this syntax a little bit hard to remember. So just think of it as that's effectively what you're doing. You're going, please find everything within passenger class that is equal to 1, and then please take the data frame and subset by that. Now, the other thing that is worth noting is that you don't have to use this .loc. So we can just run this and the code will still work. It is entirely unchanged. Now, .loc is probably a little bit what we would call safer. It's less likely to cause problems down the line. So try and do the .loc if you remember, but I may well forget because when I learned, we tended to just do this. Right, let's now just copy this because we wanted 3 data frames, one for second class where we're just going to have those, and one for third class where we're just going to have the passenger class equals 2, 3. And the last thing we've been asked to do is print the first 10 entries of second class passengers. So I'm going to do the second class data. I'm going to use my head function again, and remember we need to tell it we've got 10 rows. So I have now run that, and you can see that everyone in our output data frame is in class 2, and we have 10 rows of data. Right, next thing I'm going to do is a slightly more complex filter where I want to just keep information about female children passengers, those 16 and under. So what I'm going to do is, again, I'm going to start from my Titanic data frame. I'm going to loc, and I'm going to say, well, first I'm going to say, please look at the Titanic data frame, look in the sex column, and just give me columns, just give me rows where the answer is female. So we've got all females now. We've only got 314 rows left. I think if we go back up and look, we originally had 891 rows. So you can see at the bottom here, it displays this nice little thing telling us that we've got 314 rows and 11 columns. Now we've been asked to do another thing. We've been asked to also just restrict it to female passengers who are 16 or under. Now to do this, we first need to wrap this in a set of brackets. So this is basically just going, here's one of my conditions, and then I'm going to use an ampersand. On my keyboard, this is Shift and 7 in the number row, so I get this little and sign. It won't work if you type in and, that does not work in Pandas. You need to use this ampersand. What I am then going to do is open up another set of brackets and say, please now look for the Titanic data frame, where we are this age column that we've got here, so it's age with a capital A, is less than or equal to 16. So if I run this now, you can see that we've only got passengers, we've only got not all that many left actually. It's not shortened the data frame this time, it's automatically showed us all of them, and it is the passengers that are female and under 16. So it's important to be looking at this. You've just got to remember that if you've got multiple conditions, you need to wrap each individual condition in brackets. So this bit where we say, please look at the sex column of Titanic data frame and return those that are female, and do that just for the ones that are under 16. So it's just separate conditions are wrapped in a set of brackets themselves, and all of this goes inside this one set of square brackets. Now we could use OR. That's a pipe symbol. For me, this is Shift and it's just in the very bottom left of my keyboard next to the Z key, and this creates this little vertical line, and this would produce any instances where you're either female or you are under 16. You could be female and under 16, but basically it's you're female or you are under 16. At least I think you could be female and under 16. That might not actually be the case, but anyway, you're looking at an or in that case, but we were asked for an and. So what we also want to do is sort by age and then by passenger class. So the first thing I'm actually going to do is just turn this into a data frame of its own. So I'm going to say Titanic female children equals. And you can see now I've got a little line here in my editor. That's telling me that that's 80 characters wide. Now the nice thing about this particular kind of format of writing code is we can line break within these square brackets, and it will recognise that we're still doing this, we're still part of this same little section of code. So if I were to put a new line here and a new line here, the code will still run. It's now saved to a data frame called Titanic female children, so I'm just going to display that. But you can see that the code has still worked. I haven't had to do anything special to tell it that this all belongs to the same part of code, as long as I'm making my line break after we open this square bracket. I could also put this square bracket on a new line by itself. I quite like to do that because I think it makes it really nice and clear that everything on these lines is a condition. It can also make it then really nice and neat when you start adding in even more conditions. It's very easy to read. But we only have the 2 conditions here, so I can turn it back to that. So Titanic female children, and the next thing we wanted to do was sort the values. We've been asked to sort values by age and passenger class. So I'm going to do age, and I'm going to do P class. Because we're sorting by multiple things, I'm going to put them inside a list. If I were to just sort by age, then actually what we'd see is that we can just put this in as a single thing. We've started with the passengers who were 3/4 of a year old. And if I was just to sort by passenger class, then I would also have a list here where we've started with all the passengers in class 1, and then we start moving to passengers in class 2. Again, remembering that we are looking at just our female children, that's why we don't seem to have many in this data frame. Other thing to note is that it's sorting from 1, so it's starting with our lowest at the top of our data frame. We can do, I believe the argument is ascending. And by default, this will be true. So it's saying start with the lowest and work upwards. If we say ascending equals false, then it will start with the highest number first and count down. Now, the next thing that we can do is we want to actually sort by multiple things. So we want P class and we wanted age as well. And actually, we want to sort by age first and P class second. Now, what you can see is that we have sorted by the age, so we've started with the youngest, and where there's ties, where there are two things in the same, two of the same, so we've got a female here that was 2 years old and another female here that was 2 years old, it then counts up the passenger class next. So it will start with 1, 2, 3, 3, 3. If we were to do this in the other order, so if we sorted by passenger class first and then age, what you will see is we get everyone in passenger class 1 first, and then we've sorted by age within that class. So we've gone everyone in passenger class 1, and then we've gone 2, 14, 15, 16, etc. So the order you put these in will matter. But we've been asked for age and passenger class. The other thing to note is we can still tell it to be whether ascending or not. This time though, we will just need to pass that in as a list as well. So let's say we wanted to sort by age in ascending order. We would say age is ascending true. That's the first thing in our list. And then effectively we've said please sort by passenger class in descending order. That's false in our list here. And you can see that that has worked. We've gone upwards from the lowest age, but we have gone downwards starting. So where there are ties, we've first put the highest passenger class, and then we have counted down to the lowest passenger class. So I'm going to get rid of that because that's beyond what the scope of this exercise was, but it's very useful to know all these different ways you can do sorting by multiple things. So finally, I could do this where I say Titanic female children is now equal to Titanic female children, sort values, and so on and so forth. And if I were to now run this, you will see that sorting order has saved. I can save myself a little bit typing. Sometimes this is a better option. I can instead say, please sort this in place. So what it means is instead of us having to say, please assign this back to Titanic female children, it just says, oh, okay, I will automatically save it to the data frame that you are sorting if we use this in place argument. So what we might also get is this thing that says a setting with copy warning. A value is trying to be set on a copy of a slice from a data frame. All this means is when we ran titanicdf.loc, we took a copy of the data frame, but it wasn't like a proper copy. There's a little bit of stuff going on behind the scenes that effectively means it sort of copied the data frame, but sometimes you might find that you're unexpectedly actually making changes back to the original data frame without realizing. Now, the good thing about it is all you have to do is type in .copy. So anytime you do some conditional indexing like this, or anything where you're taking some subset of a data frame, if you just type in this .copy at the end of it, you can see this error message has now gone away because we have taken a safe copy of this data frame. Coming back to the in place thing, actually, so there's no clear right or wrong whether you should be using in place or not. However, the only thing I would caution is that if you use in place and then try assigning this back like this to Titanic female children, what you will find is that actually we now have nothing. We have no values in data frame. You see if I actually try and print this object, it now says it is a none type object. So it's just worth checking. You don't want to do both of these things. You either want to run your code like this, where you have sorted it and you have assigned it back to to Titanic female children, or a new data frame, a new variable, whatever you want to do, or you have done it like this, where you've done in place, but you have not assigned it back, because in place means automatically assign it back to this variable. So let's just run that, and that is all now fine. If I were to print this data frame, you would see that actually we have got the data that we wanted. And we've been asked to display all the records. So in this case, that is what's happened. We haven't used the .head argument or anything, and we've got all of the records showing. Now, next thing, we've been asked to remove the name, ticket number and cabin number columns from the original data set, so they're no longer in the original data, and we've been asked to display the first 10 records. So again, I'm going to go back to the original Titanic data set this time. I'm going to say drop, which means basically get rid of some particular columns, and I'm going to pass in a list of columns. So I could just get rid of one, and actually if I were to run this now, you would see that, oh, it doesn't like it. Why does it not like it? That's because I haven't told it which axis I'm interested in. So it will default to axis equals 0, which means it's actually looking at the rows. It is looking across like this. If we tell it axis equals 1, it will look down instead. It will look across the list of columns that we've got, but it will effectively be going, actually, I'm looking for columns that match what you are passing in, so it will look for the name column in this instance. So if I were to run that, and actually not have too many brackets in my code. So you can see I've passed in a list of the columns that I want to drop, and I've told it axis equals 1. You can see now that we've got our original data frame with no name column. I'm now going to get rid of the ticket columns and the cabin columns as well. So again, remember, we're passing in a list. Each one of these column names needs to be surrounded by quotation marks separately. And I'm going to say axis equals 1, so now we've got even fewer columns available. Now what we wanted to do was make this apply to the original dataset. So again, a bit like when we were doing the sorting, we could say Titanic df equals Titanic df.drop, or we could use our friend in place to automatically make that save back to that data frame. So I'm going to run this time as well. We want the top 10, so I'm going to run head 10 again. And now you can see that the Titanic data frame, we've only got those columns remaining. Next thing we want to do, count how many males and females are in the data. Now I'm going to use the value counts function for method for this. So if I go Titanic data frame, I'm going to show you what happens first if I just run value counts on it. Now all I get told is, well, nothing particularly useful, quite frankly. It's telling me, it's grouping me things by an awful lot of levels of detail, which is not the easiest to understand. So instead, I'm going to say I want to actually just count things at the value of a particular column. I'm going to count so first I'm going to just get the sex column out of my data frame. So you can see here that what we've got is just this particular thing. We've just got a column. If I were to actually run type on this so that we can see what kind of type of object this is, we will be told that it is a Pandas series. That's effectively just a fancy way of saying it's a special column object. It's a column object of Pandas. It's a Pandas column because it's still got this passenger ID associated with it. It's not just a list of male, female, female, male. It's got these other sort of special things still attached to it. So anyway, that doesn't entirely matter. It's just worth knowing why it doesn't look just like a list, because sometimes you might want to use it as a list, and you have to do some additional steps before that will work. So Titanic dataframe.sex, this time if I were to run value counts, and again remember it's a method, so I need these brackets even though I'm not passing anything into them, we get told that there are 577 males and 314 females. I could choose a different column here. I could use P plus. which gives me a rather nice 491 in class 3, 216 in class 1, and 184 in class 2. You can see it has sorted it by the counts of the columns, not the values in, well, the values we're counting by. So it's actually done it in descending order by how many were in each class. Again, we could do survive, remembering that 0 means they did not survive, 1 means they survived, and we had 549 who didn't survive, 342 who did, and so on and so forth. Doesn't work so well for columns like fair, because actually we have a lot of very specific values. We can see actually here that a lot of people paid, I'm assuming this is in dollars, $8.05 perhaps. However, because there is so much variation in the fares paid, actually we can see we've got 248 different fares that were made use of. Then actually this isn't the best function to be using with that. So instead we might look at something like a histogram, or look at categories. We might categorize it into fares that are between 0 and 10, 11 and 20, and so on and so forth. So all we were asked to do though is actually just get the value counts by sex. So that is what we have done here. Finally, or penultimately even, we are going to look at pivot tables. So we are going to use a pivot table to compare the mean age, number of siblings and spouses, and fare paid across the 3 passenger classes. So the way I am reading this is that we want to use Pandas pivot table. If I open this up, you can see that first it expects me to pass in something called data, which is a data frame. So I'm going to pass in data equals Titanic DF. What's the next thing I need to pass in? Well, it's not giving me much detail here. Can I scroll down at all? Not particularly well. So I know if I hover over here, if I've hovered over pivot table here with my cursor, it's giving me a little bit more detail about what each of these are. Next things, it's telling me values, I need index, and there's a couple of different things that might be optional. Tell you what, let's actually look at the Pandas pivot table documentation. So I've just searched Pandas pivot table, and the first thing that's come up is pandas.pivot table in the Pandas documentation. I'm going to click into this one. You can see it's purple. I've used this quite a few times before. And what I am going to do is look at what the parameters mean. So we've been asked to put in a data frame. We are then asked for the values, the column or columns to aggregate. We are also asked to pass in an index, keys to group by on the pivot table index. There's a couple of different things we could do. We've also got, we could do columns here, but if this is actually optional, and agfunc. So what aggregation function do we want? This will be mean. In our case, we've been asked for the mean average. So what does this actually mean? Well, let's start with our index. This is what we want to be grouping by effectively, and we've been told we want to group by the passenger class. So I'm going to group by P class. Next thing we know is that we want to look at the age, number of siblings, and spouses. So, and the fare as well. So I know that actually the columns I'm interested in are a list of columns, because we've got more than one, so we need to open up a list. And I'm going to say that I want to look at the age, the sib SP, which is siblings, siblings and spouses, and the fare. And the final thing, I'm going to put a comma here and I'm going to move on to a new line. I've pressed the return key, and again, because we're within these brackets, it will automatically understand that we are still passing arguments to the pivot table function. We don't have to do anything special to move on to this next line. I'm then going to say that the ag function I am interested in is mean. Now, if I run this, you can see that we get a pivot table where we have got the mean age, the mean fare, and the mean number of siblings and spouses across these different classes. Now, I could tidy this up even more by actually, if I put each of these arguments on a new line, that I just personally find a little bit easier to read. The other thing we could do, which might, let's just see if this works, might not, but it might. We could round each of these to 2 decimal places, just to make it a little bit easier to read. So you can see at the end of this pivot table, after I've closed these brackets, I've just typed in dot round, and I've said 2. I want 2 decimal places, please. I could put this to 3. I could put this to 4. If I wanted different rounding on each column, it gets a little bit more complicated, but just to make this a little bit easier to read, for now, I've gone above and beyond the task in this case, and I've just said, please can we round this by 2 decimal places. We could save this as a new data frame as well. So actually, if I go by pivot class, let's call it that. If I were to check the type of what pivot class is, so remember this output here is pivot class, then actually you can see it's a data frame. So then, of course, we can start doing anything else we want to, that we would do with our normal data frames. We could do that here. So we could pull out just the age column, for example, and it's pulled out the P class as the index. So we've got 1, 2, 3, and then we've got the average of the age column. Other useful little thing to note, if we wrapped this in 2 sets of square brackets and ran it again, instead of pulling out the column as a series object, you remember a minute ago we were looking at the fact that it was pulling out this series. If we only have the 1 set of brackets, that's effectively a special Pandas column. Effectively, each column in a data frame is a series, sort of. It's a little bit complicated. But if we instead just do 2 sets of square brackets, then we get this instead. We get a data frame back from our output. And you can see if I wrap this in the type function, then it confirms that we have got a data frame. If I just have a single set of square brackets, it tells us that we've got a Pandas series. So just keep that in mind depending on what you want your output to be. In this case, I actually just want to print the whole lot, so that is what I shall do. And again, remembering I'm not using the print statement because that just makes things a little bit ugly in the case of Pandas data frames. A lot easier to read like this. Finally, we're going to use a pivot table again to compare the median fare paid across each of the 3 embarkation points. So let's just go for another pivot table here. This time we still want the same data set. We want the Titanic data frame. I'm going to go straight onto a new line for my next argument. I want to group by the embarkation points. Now if I scroll up a bit, that column is called embark. And then all I want is the fare. So the median fare. So I want to look at the fare column. This time, because I've only got a single column that I'm looking at, I just realised I clicked here accidentally and told it to add a breakpoint, which I don't want. Breakpoint will stop my code running. That's what this little red dot is here. So I'm going to click that again to get rid of that breakpoint. Anyway, back to where we were. So this time we are asking to look at the fare column. And because we're only asking to look at 1 column, we don't need to pass an age. Remember, before we passed we don't need to pass a list even. We passed a list of age, sibling, spouse, and fare. This time we are just passing in the fare with no extra. We don't need to pass in a list because it's only 1 thing. Finally, we tell it that we want a different aggregation function. We want the median. Now, this time you can see that it's C, Q, and S, and I can't remember what these exactly stand for, but effectively these are the median fares at each of these embarkation points. We could also pass in the mean, we could pass in quite possibly the maximum, and we could also pass in the minimum. So there's quite a lot of flexibility for what aggregation function we will be using. But that's it with Pandas. That's everything that we need to do in this exercise. So thank you for joining me for the ride, and I hope you are starting to appreciate just how flexible and powerful Pandas can be as part of your data toolset. This is really fantastic if you are bringing in bits of data and need to repetitively run calculations at scale. This can really help you in combination with other tools to automate your data pipelines. So it's incredibly powerful, worth getting to know really well. So I hope I have convinced you that Pandas is a great thing to use.